As you can see, there are many more reactions in the second course of organic chemistry. Section 5 here in chapter 13, we want to talk about the preparation of diols. Before I just jump right on in, I want to talk about naming diols. If you have a diol, you want to name it based off of the parent chain here. So this is going to be a pentane diol, but we need numbers to indicate where the hydroxyl groups are. So it's going to be 2, 3, pentane diol. Okay, and here I'm not confusing the fact with any stereochemistry. So if I had something like this would be 1, 2. And remember, this is a cyclic form of a ring. So we need to write cyclo, butane, and then just tack on the word diol at the end. Okay. Some common alcohols that are diols are ethylene glycol, and the name is a bit misleading because you have that ene in there. But the reason why is because it's made from ethylene, okay? So glycols are 1,2 diols. Propylene glycol is less toxic, and that's propylene glycol, okay? So anyways, how could these diols be made? Diols can be made in 3 different ways, right? So we could react this with hydrogen and platinum. Okay, and of course we're going to be using excess hydrogen, but whenever you write hydrogen, realize that it is going to be in excess. The other thing we could do is we could treat something like this with lithium aluminum hydride and water. So it's the same deal. We're just converting each of the 2 ketones to an alcohol. Okay, and it really doesn't matter what kind of functional groups you have. We could, for example, have a ketone on the left and a aldehyde on the right. And if we treat this with sodium borohydride in methanol, we're going to form the diol. Okay, and it's good to count the carbons and make sure you're not accidentally, adding any. So the alcohol is at carbon 4 and also carbon 1. So we call that 1,4-pentane diol. Okay. Now we've talked about in chapter 9 how to make diols through dihydroxylations. Okay. We have an anti-dihydroxylation. Okay. And you'll want to have this reaction on a note card. But if you have, say, for example, cyclohexene, and we used MCPBA, which stands for metachloroperoxybenzoic acid. And the book uses H3O+, but I like to write H2O and H+. And that's going to give you a 1,2 diol or a glycol, where the 2 hydroxyl groups are on opposite sides of the ring. So we call that anti, okay? The syn dihydroxylation has a couple of different ways to do that. We could use cold potassium permanganate. There's sodium hydroxide and water and other things in there, but I just write cold KMNO4, and that's going to form a let me correct that mistake. It's going to form a cis product where the two hydroxyl groups are on the same side of the ring. Okay. The other way of doing that is with the osmium tetroxide, and usually you use the catalytic N-morpholine oxide. Okay, so osmium tetroxide is similar to KMnO4, and this gives you, the same product. So I'll draw the arrow going up. Okay. So that there's two options there. There's two options for the anti also, but I won't get into that. Okay. So that's how to make diols and a little bit about diols.